Okay, we're on Euler's method, and what we did here, I certainly graphed out the direction field, and then I used Grapher to graph a solution through this point using Euler's method, and we got a graph of it. This is the graph we got over here. Let me get rid of Sage for a second. Um, and it really wasn't that bad to do. I mean, certainly we got that. Certainly, how's it computing it? Then we went through that technique of what Euler's method's doing. I also put the exact solution down, and I showed you how they differ, how they agree at the point 0, comma 1, but as they move away, they start to differ. All right. Then we talk about how to compute this. I find it to be very tedious, but I do want to go through it with you. I'm going to be using software to do it, and we're going to Sage to do that. We're using Euler's method on this particular example, where y prime equals x plus y, and the point of interest is going to be 0, comma 1. So the first thing I do is reset. The next thing I want to do is define my variables x and y, and my two variables x and y. I have a function, and that function is a function of x and y, and that's actually a slope function. So that's going to be y, I'm sorry, x, that's a function of x and y. That's really what y prime is. And what's y prime? It's x plus y. All right, so what happens now is actually doing the computation. So I do know what the variables are, they're x and y. I know what the slope is. I know what my starting point is, and I know my step size. I'm going to put the step size in first, and I think we were using h equals 0.1. Right, the next thing I want to do is I want to give it a seed value. And the seed value I want to give it is x equals 0 and y equals 1. Now here comes my problem. I got to compute the next point. How do I do that? Well, first I'm going to compute the y, then I compute the x. What's the y going to be equal to? Well, looking at this thing over here, it's going to be equal to the prior y plus the slope. What's the slope going to be? The function, just like equation of a line, by the way, at the prior values xy times the step value. Now, let me just repeat what I just did over there. It's really in the equation of a line. Y equals, it's mx plus b. And again, we'll go through that. I'll do it at the whiteboard, and we'll derive these formulas here. But they're pretty simple, just lines. What are we doing? We're taking a point 0, 1. We're using the slope to get to the next point, using a step size, a point 1, right? What's the x going to be? X plus the h. All right. Then what do I do? I want to display. Let me get rid of clear. I want to display the point xy. Now that's my next point, by the way. So what I want to do is I want to scroll to the bottom of the page where this stuff is being listed for me, and we'll go through one step at a time. By the way. Now, granted, someone says, "Oh, you only have a few places over here." I do, but the first point after 0, 1, the next point I'd get to is 0.1, 1.1. Now I'm not going to type it in. I'm going to use the up arrow. What the up arrow is going to do is bring back that prior command. Now, x and y are different numbers, by the way. What's the x? It's 0.1. What's the y? It's 1.1. It's going to compute the next value. What's that going to be? 0.2, 1.22. I'm going to hit the up arrow again. What do I get now? 0.3, 1.362. Again, I see these numbers listed here. It's good to check it. Let's do this next one. I did the up arrow. 0.4, 1.528. And again, they're rounding it off. That's fine. Let's go to the next one. That's going to be this one over here, 0.5, 1.72. But again, I rounded it off. The reason that when you typeset something, you don't want to like a bunch of numbers padding it. You just round it off to 3 decimal places. Let me do the next one. What's that going to be? 0.6 and then 1.943. Again, I'm rounding it. Let's do the next one. What are you going to get? 0.7, 2.974, blah, blah, blah. Let's do the next one. It's easy. I'm just hitting the up arrow. I'm not doing any computation. The machine does it for me. I get 0.8 and 2.4871. Let's do the next point. What am I going to get? 0.9, 2.8158, blah, blah, blah. You get the idea. Let's do the next one, which will bring me to the 0.1. I want to go back to the notes and talk about it. All right. So using Euler's method, when I got to 1, the number I got was 3.187. You get the idea. I'm not reading that whole number to you. Now again, I have a much more precise number over here. All right. So the one's precise. But the other one, there is some rounding that I'm doing over here. But I also want to do the exact function I want to go back to that exact function, and it's this one over here. So I'm going to be typing that in into Sage. I'm going to say now the exact function. I'm going to call it g of x. Was that equal to 2 star e to the x minus 1. And what I want to do is I want to evaluate that function at the number 1. So it's going to be g of 1. You're going to notice that something odd happens when I do this. It doesn't compute the number. It says 2e minus 2. I don't want that. I want g, and I'm going to use a decimal now. So g 1.0. I'm getting this number over here. Now someone says they're remarkably different, and they did spread apart, by the way. Let's go back to where this is over here, where I actually do the computation for it. And this is part of your reading notes, by the way. When you read notes, I got to find out where that was, by the way. When you're reading notes, by the way, you're looking at these things, where they get these numbers from. I got that by computing them. That's how I got them, and you should get them by computing them as well. So I'm getting this over here. How much does it differ? Well, I'm going to just copy paste. I'm going to look at this. I'm going to type in absolute value, that number minus this number over here. And what do I get? I get, roughly, that's a pretty big spread, by the way, roughly 0.25, all right? Now, if you go back to the graph, let me talk about what I mean by that. The graph where we're using Euler's method at the number 1, if you look over here, I can't even see in the graph, by the way, but if you went to number 1, these two graphs here, they'd have a vertical spread over here of about a quarter, all right? It gets bigger and bigger as we start to move away, by the way. Thank you.